Welcome students to the lecture on sensors. Students, the other day I was watching a cricket match. So immediately after the bowler threw a ball, I was just observing the speed display there. In fraction of seconds, you're able to trace or track the speed of the ball. If not for a Doppler sensor there, it is not possible. Students, you want to know the attendance of the stadium? Yes, there should be some sensor there. Yeah, there is a counter device trying to sense whenever an object passes through it, giving you the attendance of that stadium. Possible. Students, imagine you are traveling in an aeroplane, right? And then you want to know at what height you are from the sea level. I remember there are frequent announcements in the aeroplane regarding at what height you are. Possible with the help of some sensors. And there are some sensors giving you the pressure inside the aircraft. Whether it is in a rocket or an aircraft, you want to know the pressure, there are pressure sensors doing the task for you. Student, in our daily life, sensors play a very major role. Students, from high-end engineering applications to our daily life applications, we find sensors everywhere. Students, just imagine there is a camera trying to capture your image. So you just try to put your hand like this. Your gesture is being recognized by the camera. There is a gesture sensor recognizing, and the camera doesn't work for a moment until you remove your hand. Students, now in our daily life, we are using a number of electronic gadgets which involve a number of touch sensors. Your mobile phones, for example, has these tactile sensors, we call them. Okay, just the pressure you apply is being recognized. Whatever app you want to open, you can just with a little pressure, you can just do it. So these are all touch sensors. So from the generation of touch sensors to gesture sensors, we are almost moving with the advancement in technology. We are almost moving to the generation of thought sensors. Now, in this juncture, this lecture will help you in understanding how to define a sensor. What actually is the difference between a sensor, a transducer, an actuator, and how do you basically classify the sensors? So students, now let us try to understand the definition of sensor. So how do we define it? Sensor is a device that receives a stimulus and responds with an electrical signal. As you see here, the stimulus is nothing but the input you give to a sensor. And now your output is definitely an electrical signal. So we define sensor as a device that receives a stimulus and responds with an electrical signal. So now the stimulus or the input you are giving to a sensor is also called as measurand. What is this stimulus or measurand? So it may be a quantity, a physical quantity, it may be a property, it may be a condition. For example, take light flux, you can take temperature, You can give the pressure as input. You can give the conditions like vibration as input, quantities like displacement, position, velocity, ion concentration. All such inputs you are giving are called stimulus. Now, what is the output now? The electrical signal. It may be voltage or current or charge. So now the characteristics of this electrical output may be amplitude, frequency, it may be phase, it may be a digital code. Now these characteristics are called output signal format. So now students, let us try to understand the difference between a sensor, an actuator and a transducer. As we just learned, sensor is something that takes a stimulus and gives us an electrical signal as output. Now, something that functions exactly opposite to the sensor, in the sense that takes electrical signal as input and gives a non-electrical output, is what we call an actuator. And now what is a transducer then? The transducer will take any energy as input and the output will be any other form of energy. That is the basic difference between a sensor, an actuator and a transducer. So now let us try to classify sensors. Broadly, sensors are classified into passive sensors and active sensors. What is a passive sensor? Passive sensor does not need any additional energy source and directly generates an electrical signal in response to an external stimulus. That is, the input stimulus energy is converted by the sensor into output signal. Now the best examples: thermocouple, photodiode, piezoelectric sensor. Now what is an active sensor then? So active sensors always require an external power for their operation, which is called an excitation signal. That signal is modified by the sensor to produce the output signal. In a short while, you'll understand the best examples I demonstrate, but before that, the examples of active sensors are thermistor and strain gauge sensor. Students, now let us try to understand the passive sensors and active sensors with some best examples. Say for example, we have a thermocouple. What is a thermocouple? See in the diagram, you see two different wires. So there are two wires made of two different metals. Say one is iron, the other is copper. Or it may be a combination of any two dissimilar materials. So you just combine them in such a way they form a junction here. So now whenever you try to combine two different material wires, at the junction there is a transfer of electrons from the material having high number of electrons to the material having low number of electrons. So now there is a voltage developed at the junction.
And now this voltage again depends on temperature. So I take two dissimilar material wires, join them in such a way they form a junction, subject one junction to high temperature and the other ends to the low temperature. Current starts flowing through this combination. Such a thing is what we call Seebeck effect. Now this combination of dissimilar material wires is called thermocouple. Students, in this example, all we are trying to do is just give a temperature change as stimulus, and we are getting an electrical output here. We are not taking the help of any excitation signal in this example. So this is the best example of passive sensor, thermocouple. And if you want to see how a real-time thermocouple looks like, this is something like this. We'll be using such thermocouples in a number of engineering applications. Now, to understand the difference better, we'll discuss an example of active sensors. As I said previously, thermistor is one of the good examples of active sensors. So you see this component is called thermistor. Thermistor in the sense thermal resistor. So the resistance of this component changes with temperature. Thermal is something heat related. So when I raise the temperature, now the resistance of this component changes. So when the resistance of this component changes, obviously the current passing through this circuit also changes. So now here in this example, the thermistor is a sensor and I am calling it as an active sensor because we are using some excitation signal here. So the current is trying to pass through this sensor, and now whenever there is a temperature change, so the stimulus here is the temperature change. Whenever there is a temperature change, now this excitation signal is modified, and that modified current signal is observed in this microammeter. So now, unlike passive sensors, active sensors require an excitation signal, as in this example. So there is a basic difference between a passive sensor and an active sensor. In passive sensors, we just raised the temperature of this junction, we got the electrical output. Now here, there is an excitation signal, for example, the current passing through it. Now without this excitation signal, thermistor do not respond. So you are trying to send current through the thermistor, and now you are changing the temperature of this thermistor. Now the temperature change is reflected as the modification in the current signal. So that is the difference between an active sensor and a passive sensor. And the real-time thermistors look like this. Now let us try to understand the difference between passive sensors and active sensors with more examples. Students, you see the other example for passive sensor is piezoelectric sensor. This is how it looks like. Just a little pressure on this surface will generate the voltage. So it can also be called as a pressure transducer. So you are giving pressure as an input, and now you are getting an electrical output. Because there is an electrical output, you can now call it as a sensor. Now this is a piezoelectric sensor. Now piezoelectric crystals are the ones when subjected to a mechanical strain, they give us an electrical output. Now the other good example for a passive sensor is a photodiode. These are some of the real-time photodiodes you see there. When light is incident on them, it gets converted into electrical energy. Solar cell is also one kind of photodiode. We call it as a large area photodiode. So simply the light energy being incident on these photodiodes get converted into electrical energy. Now the other example for active sensors. The other best example is strain gauge sensor. Students, you see this component, little component here, it is called as a strain gauge. So there is a thin conducting metal wire. As you see here, we'll discuss more about strain gauge and pressure sensors in detail. But for time being, to understand what an active sensor is. So this thin metal conducting wire is what we call a strain gauge. Now it has some resistance. And now if you can recognize, this is called a Wheatstone bridge. Now this strain gauge with some resistance is the fourth component of this Wheatstone bridge. Now you are trying to send the electrical signal to this Wheatstone bridge arrangement. So now whenever I try to change the temperature or the length of this element of the strain gauge, imagine I subject it to some strain. So that is reflected as the change in the resistance. So whenever there is a change in resistance, obviously the electrical signal is also changed. So there should be an excitation signal here. So the current is passing through this network, is the excitation signal. And now that current gets modified if there is a change in the resistance of this strain gauge. So without sending any current through this combination, you can't recognize the changes in the temperature or the pressure you are subjecting the strain gauge to. So this is another good example of active sensor. A real-time strain gauge sensor looks like this. Now let us try to understand the other classification of sensors. Absolute and relative sensors. One classification we just completed is passive sensors and active sensors. The other important classification is absolute sensors and relative sensors. Generally, an absolute sensor detects a stimulus in reference to an absolute physical scale that is independent on the measurement conditions. To understand better, look at this diagram. Both are thermometers. One is showing the temperature in Celsius scale, the other one is Kelvin scale. If you take the Celsius or the centigrade scale, the minimum temperature is minus 273 degrees centigrade. It's not 0 degrees centigrade. You can achieve temperatures below 0 degrees centigrade. And the least temperature that can be achieved, remember, is minus 273 degrees centigrade. Now with this minus 273 degrees centigrade is nothing but 0 Kelvin. So you see the difference between the absolute scale. Now this is called the absolute scale and this is the relative scale. In absolute scale, 0 Kelvin, there's nothing you can talk below that 0 Kelvin. Whereas in centigrade scale or in the relative scale, below 0 degrees centigrade, there is some temperatures you can talk about up to minus 273 degrees centigrade. So remember, this is absolute scale, absolute temperature. The scale here, the gradings on this scale gives us the absolute temperature. And now this is relative scale. Now coming back to the definition, an absolute sensor detects a stimulus in reference to an absolute physical scale. So if I am giving temperature change as the stimulus, now that is in absolute scale. And I can give you the best example of absolute sensor. We just discussed thermistor. So thermistor, it's a temperature sensitive resistor. The electrical resistance directly relates to the absolute temperature scale of Kelvin. So thermistor can be called as an absolute sensor. Students, now you see another picture here where I am trying to show the pressure scales. So now here the pressure is in bar as well as here in bar. And we have here the absolute scale here. This absolute scale, it is 0 bar, 1 bar, 2 bar, 3 bar. The scale goes like this. Now this is the relative scale where 0 stands for the atmospheric pressure. The 76 centimeters of Hg, something we learnt in lower classes, is the 0th reading of the relative pressure measurement. Relative to that 76 centimeters of Hg, we can measure the pressures in this scale. As you see here, being a relative scale, you can find calibrations above 0 as well as below 0. But here in absolute scale, the scale starts with 0. There is nothing you can talk below this. So I'll give you the best example of a relative sensor. But before that, a relative sensor produces a signal that relates to some special case. In the sense, imagine I take a relative pressure sensor, produces a signal with respect to a selected baseline that is not 0 pressure. For example, I take here as the baseline. Now it's not 0 pressure, right? It is the atmospheric pressure is taken as the baseline here in this relative scale. Such pressure sensors are called relative pressure sensors. So the other way of classifying sensors is absolute sensor, relative sensor. So absolute sensor detects a stimulus in reference to the absolute physical scale, whereas relative sensor produces a signal that relates to some special cases like this. Students, this is the end of lecture 1. So now in this lecture, we learned how to define a sensor, how to classify a sensor, and we also understood how to differentiate a sensor to an actuator. Remember, sensors are broadly classified into passive sensors and active sensors. Passive sensors do not require any excitation signal, whereas active sensors require an excitation signal. Thank you, students. We'll again continue this topic of sensors in the lecture 2. Thank you.